No. Guys, am I audible? I'm waiting for your explanations. Let's try to keep it interactive. So, see, there are 15 people in the live stream. Okay, nice. Vignesh is there in the chat. Okay, so, uh, yeah, in this live stream, we will discuss all the four problems of today's contest. So, starting with the very first problem of the contest, that is find indices of stable mountains. The problem says that there are n mountains in a row, and the height of the ith mountain is given the height of I. And we have been told that a mountain is considered to be stable if the mountain just before it, if it exists, has a height strictly greater than threshold value, which would be given to us as a parameter. And we will have to tell the indices of all these stable mountains in any order. And the first mountain, that is mountain 0, is not stable. So it is like we are being given an array, and the ith, the element at the ith index tells us about the height of the ith mountain. So we are just told about the heights of all these mountains. The first mountain is not stable. For all the other mountains, uh, like we decide whether these are stable or not on the basis of the height of the previous mountain. If the height of I minus 1 is greater than, just greater, not equal to threshold, strictly greater than threshold, then this mountain I would be considered to be stable. So we will just push the index inside a vector of integers and it will be answer. So yeah, basically we can just iterate over the array from left to right. For every index, we can check the value of the previous index, whether this is greater than threshold or not. If it is greater than threshold, then like we can maintain an answer of a vector of integers with name answer, and we can push this index inside the answer vector if the height of the previous mountain is greater than threshold. So does it make sense? Okay, so when you saying a keyboard, yeah, the difficulty of Leetcode contest has increased. I'm giving the contest after a few minutes, and I was surprised to see that the B problem was having graph algorithms in order to solve it. So second question will be this answer. Yeah, second problem cannot be solved. Okay. Tell me about the first problem. Those who are in the live stream, guys, tell me whether this problem is clear or not. Let me show you the code as well. So what I'm doing is I'm just iterating over the array, and I have been checking if the element on the previous index is greater than threshold, then the current mountain is stable. So push it inside the answer, the answer vector, and return it. You need to make sure that you are starting the loop from one, or like in whatever way you run the for loop. Just make sure that you are never checking height of minus. Like you should uh, never have this problem. Basically, if you start, let's say start at the for loop from 0, in that case, when I is equal to 0, it will become height of 0 minus 1, that is minus 1, and this will give you an error. So you just need to make sure that you don't make this mistake. The time complexity here is perfect. The space complexity here is in if you are considering the space complexity for creating this answer vector. Okay. Your voice is not clear. Okay. Let's check this. I have switched to the headphones, so it should be. Guys, is my voice not coming good for everyone or only one person is facing issue? Okay. Why is the live stream not on Zoom call? We are starting free for all PCDs, live PCDs free for all. So currently we are doing it on YouTube directly. Using the first term person. Okay, let me check the audio quality once. Okay, let me check the audio quality once. Guys, in my device, I see that audio, like the audio quality is looking good. Okay, you are saying about the video quality. Someone is saying for video quality. And someone is saying for- Unfortunately, I can't do anything for video. Yeah, by the way, is anyone having any doubt in the first problem? Shall we go to the second one? I don't see any doubts in the chat, so I'm assuming that it is clear to everyone who is in the live stream right now. Okay, so the second problem says that we are given a binary matrix grid and an integer health. We start from the upper left corner and we would like to go to the lower right corner, and we can move in all the four directions, up, down, left, or right. And uh, yeah, we can move as long as our health remains positive. And the cells ij with the cells uh, whose which are having the values from basically, like uh, this cell which is having I equal to 0, j equal to 1. Here grade ij would be equal to 1, so it is considered to be unsafe and it will reduce our health value. We have to return good if we can reach the final cell, that is the last cell, the lower right corner, with a health value of 1 or more. Otherwise, we have to return false. So, is the problem clear? I think this problem is not difficult to understand, the problem statement. And they have given a very good example. Let's say this is the matrix. Then you can go in this way such that you don't come up across any of the ones, and your health, which was initially 1, would remain 1 while reaching the end. So the answer will be true in this case. In the second case, uh, according to them, it is never possible to reach from upper left corner to lower right corner while having a positive health. Basically, if your health is equal to 3, you want to go from top left to bottom right, uh, and you should not encounter more than 2 number of ones. So you can try out all the ways you want. Like I'm thinking about this way or this way. Like in all the ways, there are at least 3 number of ones you are coming across. So while reaching the end, your health will be equal to 0. So uh, that path is invalid. And then there is third example in which our health is initially 5. And if we go from top left to bottom right, we are coming up across 4 number of ones. So our health at the end of the day would be equal to 1. So the path will be valid and thus our answer is true. Okay, so is the problem clear? Guys, if you write yes, no in the chat, then it would be better. Like we will have more interactive class. Otherwise, you won't really have much to gain by attending the class live. In get problems, it is quite confusing if we should be using DP or graph algorithms. Yeah, I will tell you one thing from my experience on how I decide whether I should use graphs or DP. So whenever I come across a graph, a matrix problem, which is related to finding some path, the few things which come up in my mind are backtracking, maybe solving the problem using backtracking. Yeah, by the way, I'm talking about the problem where I have to go from top left to bottom right. You see a lot of problems in which you are given a matrix and you have to go from top left to bottom right. Um, One thing which comes up in my mind is backtracking, basically checking all the possible paths. This is generally too slow. So for the problems like this one where n and m are n is less than 50 and m is less than 50, backtracking solution would be too slow. Then the next thing which comes up in my mind is dynamic programming. Generally, backtracking is not useful. Like, I don't really see a lot of problems which can be solved using backtracking. Generally, the constraints are huge. The next thing which comes up in my mind is dynamic programming. It is generally useful when you either can go towards right or down. Like if I have to go from top left to bottom right, then if I am able to go only towards right and downside, then generally DP is useful. But for the problems where we can go in all the four directions, DP is generally not used. And currently, I'm not able to think of any problem where DP is used. Unless the constraints are too small such that you can apply bitwise DP. In the cases where you can go in all the four directions and the problem is related to path, the thing which comes up in my mind is maybe using graph algorithms like DFS or BFS. Okay, let me look at the chart. Do we need to find the path? It includes minimum number of points and compare everything. No, you don't really have to find out the path. And actually, even if you were required to find a path, it is possible. I will tell you about this. Okay, so guys, is it clear till now? Like, does it make sense? Or maybe there is not a lot of stuff to think about it. Just share my experience here. So I would tend to think about graph algorithms like DFS and BFS. Now, in the problem, we were having some zeros and ones, and you wanted to tell whether you can reach from this place to this place such that in the path, whichever path you follow, the number of ones in that path should be less than health, you know, so that you will have some positive health left at the end of the day. So one idea which I got in my mind is that from here till here, what if I just find out the shortest path, or basically the path with the least amount of ones I get? Like, what if I find out the path with least number of ones? I just got this idea. The reason why I got the idea straight away can be that I have solved a lot of problems and I instantly got Dijkstra in my mind. Now, for the ones who don't know how to use Dijkstra, I would suggest you to just search about this on YouTube and you will get some really good guide videos. One of the ones which I suggest you is Take You Forward. You can watch his video on what is Dijkstra and how we implement it. And the other algorithm which can be useful here is 01 BFS, which is useful specifically here because we are having only zeros and ones. You can search about this as well. You will get a video free of. That's explained it very well. The extra is useful even if there were other numbers other than just zero and ones. Let's say if the numbers could have been anything, any integer, then the problem could still be solved with the extra. In this case, it's up to you whether you want to apply 01 BFS or the extra. Now, I'm just giving you a few prerequisites on what you can do so that you would be uh, good to go for solving the problem. Make sure to learn about the extra. Yeah, I'm talking about this if you already know about graphs and DFS, DFS. If you don't know about DFS, BFS, and graphs, then yeah, you can skip this problem for me. Because you should at least have a good base before coming up to the problem. You can come up to this problem later on once you are covering graphs part. So you should know about the extra or zero one BFS. Any of them is fine. Secondly, you should know of uh, like applying these search algorithms on metrics instead of a graph, or basically treating the how to uh, treat the matrices as graphs. So if you are good with this, then it is fine. For knowing about this, you can just search about some problems like number of islands. You can just search about this on Chrome. The problem where you have to find out the number of islands, you will get plenty of problems which are similar to this on Leetcode itself. Just see that you should be given a matrix in the problem and you should be asked to find out the number of islands. You will know what it means to search the problem. So solve this problem first. Learn about the extra and implement it on your own. Once you're done with both of these, then come up to the problem and you should be able to solve it on your own. This way, you will have the maximum learning while solving the problem. Okay. That is the motive in solving the problems. About you learn about more things. N is less than 50 and N is less than 50 are my constraints for backtracking. Yeah, these are pretty huge for backtracking. Because in backtracking, we would be considering all the possible paths. Someone is saying he solved second problem with DP. Okay. I don't really try to think much about solving it with DP because I have a good experience of this kind of problems with DP. So, yeah. If you really did solve it with DP, then please share the solution with me as well. Solve using DP2. Okay. Yeah, that's a nice thing. Maybe I will try to look at this after the please do it with BFS. I didn't try this with BFS. Like you cannot apply a normal BFS, but you can apply a 01 BFS and it will work fine with it. The extra can be applied straight in a straightforward way, so you can use the extra as well. CFPCD. The code sources PCD will be uploaded tomorrow in a normal way as it is. Okay, so that will be BFS. Yeah, like it's up to you if you want to solve it with binary BFS or the extra. Both of them are fine. Your voice is a bit muffled. Okay, so one reason which I can think of for this might be my internet connection. Right now, I'm using the mobile data for the live stream. This might be the issue. I will look at it after the stream and will make sure that this does not happen next time. Okay, so guys, anyone having any doubt in this problem, or should we move on to the code? Yeah, for this problem, I didn't really have much to discuss because this is a straightforward conceptual problem. If you know about this thing and this thing, then you can already solve the problem. You don't really have to simplify the problem using some solutions. So it requires namespace to store all the distances. Add the matrix and compare with health. No, you don't really have anything to do with the matrix, but yeah, the thing you said of uh, using nm space for storing the distances, yeah, it is correct. Okay, let's go to the code then. So I had coded this during the contest, so my code is not very clean right now, but uh, I will rewrite this after the stream and I will provide you a very clean code which you will be able to access from the description. For now, let's be able to. I'm having a visited array as we have in dynamic, in the X and I'm having a distance array again in the same way as we have in the X and a parity queue. And this is just something which I did because I wanted to create. Yeah, this is just implement specific. You don't really need to implement it in the same way as I have done. You can create your priority queue of pair of int comma pair of int comma int. Generally, you will see people doing it in this way. So, yeah, just ignore it for now. I just use this part for making a priority queue of pair of integer comma integer. And while I traversing over matrices, we do create this dx and dy arrays. Again, this is implement specific. Some people might have different implementations. And then I'm just going up for each and every node, checking if it is already visited or not. If it is not visited, visit it and go to its neighbors. You got the new distances, so you will just check if the new distance is less. If it is less, yeah, if the new distance is less, in that case, you're updating the current distance and pushing it. Yeah, all of this is basically implementation only. So the ones you know about the extra can implement it on their own, and for the ones who don't know about it, you can just learn about it and take it further. I would highly suggest you not to focus a lot on my code and implement it in the way you like. Different people have different preferences for writing code. So, like the way I have been preferring to just convert into pair of int and pair of into int might not suit it. Yeah, I'm coming up to the part of time complexities. If n is like the number of nodes we have here, the number of vertices we are having here is n into n, and the number of edges we are having here is 4 into n into n, right? So the time complexity here would be whatever time complexity we have in the extra, which is something like v log e or e log whatever, e log whatever it is. And like this time complexity also depends on the way we implement. I think in my case it should be e log e, and the space complexity is simply big of it should be just big of okay, so someone else is also e log e. In my case as well, it should be e log e, but I think some people do some optimizations to make it Okay, so is anybody having any doubt in this problem, or shall we move on to the next problem? Yeah, see, 01 BFS is useful whenever you are having the weights of the edges as either 0 or 1. Like right now, in the problem, what are we doing? We are just thinking that while going from this place to this place, from this cell to this cell, whatever is the value of this cell, you are just thinking that hey, this is the weight. The weight is 0 here. And when you are going from this cell to the cell which is here, you are just considering the weight to be 1 because you are getting a 1 in the top. You know? So 01 BFS can be used for finding out the shortest path whenever the weights are either 0 and 1, and the time complexity for 01 BFS is just simple V plus A, as we have in BFS, a normal BFS. So the time complexity in case of 01 BFS would be V plus E, which is simply an into, like you can write it as an into by discarding the 5. But since the constraints are not that huge in this problem that you face any trouble with the log of n factor. So that's why BFS is also okay. And the reason why I use BFS the X-ray is because the X-ray is very common. Like uh, even if you didn't have a 0 1 a binary matrix, even if the matrix could have all the numbers till 1e9, that the X-ray algorithm will still work out, whereas 01 BFS will not work. So this is the reason why this prefer the X-ray over 01 BFS if time complexity is not really a big problem. Okay, so is your doubt satisfied? Shall we move on? Yeah, let's move on to the third problem. Find the maximum sequence value of array. In the problem, we have been given an integer array mass. So we have been given an integer array, let's say mass, and a positive integer k, and we have been told the value of a sequence of size 2 into x is this thing. We have to return the maximum value of any subsequence of nums having the size 2. So indirectly, like basically the problem is saying that you will be given some value k. Let's say k equal to 1. So you will have to choose 2 into k number of elements in the array, and let's say the values for 1, 2, 3, 4, 5, 6, 7. You chose these two guys, or maybe k was equal to 2 and you chose these four guys. Then take them out, take these four values out, and you got the sequence. Now the score of this sequence will be equal to the like for finding the score of this sequence, find out the bitwise OR of the first half sequence, like if the sequence is containing 2 into x elements, then find out the OR of the first x elements and the OR of the next x elements. Let's say the bitwise OR of these elements came out to be 3 and the bitwise OR of these elements came out to be 7. Then take the bitwise XOR of these elements. We will take the bitwise XOR of these. So in this case, the bitwise XOR will come out to be 4. That is the value of this sequence or the score, whatever you say. Let's say we call it as the score of the sequence. So among all the possible sequences, like you have an array of size n and you have to pick up 2 into k elements. So there are this many subsequences of size 2 into k, and among all of these you want to find out what is the maximum possible value you can have, the maximum possible value or score. Like the problem said it as value, but I would be using the word score a lot of times in the explanation. You have to figure out the maximum score of any of these subsequences or all of these subsequences. Okay, does it make sense? Is the problem clear? Guys, say something yes or no. I'm waiting for your responses. Since this is a live stream, let's try to keep it more and more interactive so that you will have some benefit of new live streams which are starting. Okay, so yeah, just as a disclaimer, the problem is difficult. The previous two problems were simple, but this one is going to be difficult. The same problem once came in Google A, as I remember, or in one of the online assessments somewhere. And yeah, it was difficult. So, let's look at the obvious things. Since we have been given an array, and from the array we have to pick up 2k elements, a subsequence of 2k size. One idea which we are already getting, like the idea which is already looking intuitive to me, is maybe the problem could be of dynamic because it is quite common that you get some array and you get some condition that you have to pick up maybe x number or k number of elements, whatever, depending upon the problem, and you have to find out some maximum score or minimum score or the number of subsequences. This thing is quite common in DP, so it already comes up in my mind that out of all the possible intuitions I get or ideas I get, I will definitely try to think about applying dynamic problem. So as I will get this idea that maybe the problem could be of dynamic, I will definitely look at the constraints. In this case, the constraints are as follows. N is gonna be less than equal to 400, and 2 into k is also gonna be less than equal to n. So basically 2 into k would be less than equal to n, and n would be less than equal to 400, and the values of the elements would be less than equal to, actually less than 2 raised to the power 7. Okay, so one thing is, since the constraints are also pretty small, it is also giving us more confidence for thinking about the DP solution, that maybe we could apply some 2D or 3D DP. Secondly, the problem setter decided that the values of the elements should be very small. These are very small values. These are smaller than 2 raised to the power 7, that is 128. So there should be a reason behind it now. The problem setter should have got a reason for putting up so small values. So this, like, if you have not done too many problems, then this might not look intuitive. But for the ones who have solved a lot of problems on DP, they might also be getting some more confidence for DP that, hey, this the values of the elements will be very small, which means that the bitwise or of the elements in the bitwise or like these values which we were calculating, they would also be less than 2 raised to the power 7. No, because if you have two numbers x and y and both of them are less than 2 raised to the power 7, then like whether you apply the AND operation, yeah, whether you apply the AND operation or you apply the OR operation or you apply the XOR operation, in all these cases the result would still be less than 2 raised to the power 7. You know? So yeah, for the people who would have done enough practice, they would be getting the idea that maybe uh, uh, like in the DP there can be a state which should be less than equal to 2 raised to the 2 raised to the power 7, less than 2 raised to the power 7. So I'm just telling about the uh, things from which I was getting more and more confidence for DP. Obviously, I didn't just straight away go to DP. I did still try to think of some greedy idea that can we solve the problem greedily. Now there can be tens of ideas you get when you try to solve the problem greedily. One of the things which I had tried is I thought that whatever answer I will have at the end of the day, it would be something less than 2 raised to the power 7. Basically, the answer would be a 7-bit integer, right? So maybe try to maximize the answer by making sure that there is a 1 it, like the most significant bit is set. Then think about the next bit and then next bit. Basically, think bit by bit. I would have liked to discuss more about this greedy solution, but as I thought about this and tried to think if it can work, it was not even close for solving the problem. So, uh, like all the discussion which we would have made on this would not really help us for solving the problem or for solving some similar problems. So for now, we are skipping that part. But you got the idea that you could have thought of some greedy solutions, but at least in my case, it didn't work out. Okay, somebody saying for greedy, for every date the answer will not be uniform. Not okay. Uh, yeah, that's what I'm telling. That I tried to think about greedy solution, but it did not work out. So I was getting more confidence that okay, if greedy solution is not even looking close for solving the problem, then there are more chances of this problem being a problem related to dynamic programming, or basically the intended solution to be of dynamic programming. So that is when I started to think of solving the problem using dynamic programming. Uh, yeah, now I'm just setting up a few prerequisites for solving this problem. Like for the ones who are watching the video, everyone will have different level of experience for dynamic programming. Some people would be just starting with DP. Some people would have a lot of experience, would have solved a lot of problems. For now, I'm just saying that I'm expecting that the ones who are attempting this problem should have solved all the standard problems, like at least this much. That you should have solved all the standard problems of DP from CSES. If you have solved these, then you should probably be good to understand the approach which I will be discussing right now. But if you have not solved even this much yet, then maybe you can skip the problem for now and focus on the basics first. Right. Uh, yeah, I'm just telling this once again. Don't get disappointed for not being able to solve this problem if you have not solved the basics yet. Uh, so, yeah, now I'm assuming that you're at least this much experienced. So, yeah, one thing which you would have already noticed a lot of times while solving DP problems is a very common way of approaching is to have uh, a DP state in a way that, let's say, you know about the answers till this point. Basically, you have calculated something till this point, and you want to calculate something this till this point. Basically, we are trying to think of some states which we would use for solving the problem. So one of the dimensions for the DP array which we would create is which I would like to create is the number of elements I have covered so far. I is the okay. I will write this here. Yeah. Let's say you have covered this much array, and now you want to uh, yeah, maybe I can discuss this. The way in which we think about in the way in which we approach the DP problems can be very different, like very different from person to person. So I'm not sure if everyone would be able to relate with me or not. But according to my experiences till now, whenever we are having problems related to subsequences, and we are approaching the problems using DP, we tend to have two things for every element. What if we pick this element in the subsequence, and what if we not pick it? Like, what if we don't pick it? Right? Are you guys able to relate with me right now? How many of you are with me right now, trying to understand this problem, and have understood the part till now? And how many of you are already lost? Just tell me in the chat so that I can decide accordingly on whether to repeat the previous problem. Okay, pretty strong. Great. What about others? Is there only one guy? Okay, let's have a 1 minute break. Um, in the meanwhile, guys, please write down in the chat whether you are with me right now or not. If you're lost, then tell me at what part you got lost. Okay. By the way, the next problem is going to be simpler than the current. The current problem is a bit difficult, and I think it would not be intuitive for a lot of you. The part which we will do for solving the problem. Okay, let's continue. So yeah, if you have solved the problems, you would have noticed that a lot of times while solving the problems related to subsequences, we do try to have two choices for each and every element. Right? And uh, looking at the condition, or basically the way in which we calculate the score, you know that uh, you don't really care about the actual values you pick up. Like if let's say you picked up four elements in for your subsequence, you don't really care about the actual values of the elements. You only care about the bitwise OR of the first two and the bitwise OR of the next, like the last two elements. Right? Does it make sense? You only care about the bitwise OR of the first x or k number of elements if you are picking up 2k number of elements in your subsequence, and the bitwise OR of the last k elements. Right. This is the idea which I had while thinking about the DP state. Now, when you would be picking up these elements while going from left to right, uh, what things can we do? Like, you must have a dimension I which tells you the number of elements you have covered so far. The number of elements covered so far in the DP state. Another dimension which you must have is, let's say, small k, let's say x for now, which is the number of elements you have picked up. You have picked up so far for your subsequence. Like we have to pick up two k number of elements. So the number of elements which you have actually picked up so far. And another thing which we noticed is we don't really care about only the bitwise or of, like, we do care about these two things now. Instead of storing all the elements which we have picked up, we only care about the bitwise or of the first k elements and the bitwise or of the next k elements. So you would like to store another dimension, like there will be another dimension which will be or basically another parameter for the state, which is the bitwise OR of the first k elements. For the first k elements, and similarly you will have OR2, which will be for the last k elements, right? So we can have something like dp of I x or1 or, and while making transitions, you know that whenever you pick up an element, if the new value of this x, let's say, okay, let me write both the things. We know that we will have two types of transitions. The first transition can be not pick. In the case of not pick, uh, this state would be just contributing to dp of I plus 1, right? X or 1 and or 2. Since you didn't pick up any new element, the number of elements picked up so far will remain the same, and the bitwise OR of the first k elements and the last k elements will also remain the same. Just the number of elements covered so far will change, right? And in case if you pick, in that case, dp of I plus 1, and you have picked up a new element, so it will go to x plus 1. Make sure that here, like, there is a condition that if x is less than 2 into k, only then you can apply this operation of picking up. And then you will have or1 dash and or2 dash. Like, depending upon the value of x plus 1, like if this thing is less than equal to k, then the bitwise or basically or1 value will change. Otherwise, If x plus 1 is greater than k, in that case, odd 2 value will change. So you can just get the new state easily. Yep, we will have these type of two transitions. Now the only problem is how many states are we having? For I, there can be 400 different possible values. Actually, 401 because I might be equal to 0, and in the end, it can be equal to 400 as well. You know, for the value of x, it can be as small as 0 and can be as large as 400 at the end. So, again, we are having 400 possible values. For OR1, yeah, by the way, in this DP state, what do we need to store? What do you think we need to store? You have 30 seconds, try to think about it. I think I should have discussed this at the time of when I created the DP state. In the meanwhile, I'm talking about the possible values of OR, which can be as small as 0 and as large as 127. So there are 128 possible values, and for OR2 as well, there are 128 possible values. Right. So there are roughly 400 into 400 into 128 into 128. So this was coming up to be like, these three were coming up to be around 1E7. So it should come around 1E9 number of states, which is definitely right. It won't work. So we must try to optimize it. And by the way, in this state, what are we covering right now? We are saying that among the first I number of elements, we have picked up X number of elements, and the XOR of the first few first k elements is over1, and the XOR of the next x minus k number of elements is over2. So what do we need to store as the result of this statement? It is simply true or false. Whether it is possible to pick up some elements from the first elements, it is now stating that whether it is possible to pick up x elements from the first I elements of the array such that the XOR of the first, sorry, OR of the bitwise OR of the first k elements is over1, and the bitwise OR of the next k elements, or at least the elements which we have picked up, is over2. Whether it is possible or not, we are just storing that in the DP array. I know it would be looking complicated. It is complicated indeed. Now let me look at the chart for now. Yeah, the third state, this is OR value, bitwise OR, and this is also bitwise OR of the elements which we have picked up. N square into 64 into 128. 64, right? Yeah, we are getting n square into 128 into 128. This will fail, right? So this is where I had got stuck when I was solving this problem for the first time. And then I just had one idea that instead of having both of these things in my state, what if I think in a different way, that I pick up like from the first I elements, let's say pick up k elements, and the XOR of them is, sorry, bitwise OR of them is I. What if I just store true or false for this? Like, is it possible to choose k elements from the first I elements such that their bitwise OR is equal to over1? Whether it is possible or not. If I do something like this, if I create a DP of I over well for the first I elements, and I do the same thing from the right hand side. So from the right hand side, um, let's I'm calling it as DP of R, basically reverse DP, uh, which is telling me that from the end among the n minus I elements, like these are just n minus I elements. From them, if I pick up k elements, rather is it possible to have over 2 as the bitwise or yeah, this might not be intuitive for most of the people. This was the tricky part basically. Everything till now, till this point, was standard. Uh, Not many people will try to think till this point because the states are too much. But when you're not getting any other solution, you would obviously at the end of the day you will try to think of all the possible solutions you can think, even if it is not very optimal, and try to optimize it later. So uh, this was the tricky part that yeah, maybe let me cover one more thing. Maybe if we didn't care about the time complexity and we had just used the same DB solution which we were just discussing a little while ago, like this one, what would we do at the end? Like, what are we planning to do at the end? We wanted to find out DP of n2k over 1 and over 2. Now, for all the possible combinations of over 1 and over 2, we would like to check if there is any combination over 1 and over 2 where uh, like from this DP array you can find out whether it is possible or not. And okay, so maybe I can discuss it. Okay, so uh, are you guys with me right now or have you got stuck somewhere else? If everyone is with me right now, only then we should cover this. Otherwise, I might have to recap somehow. Oh, nice. Sure, I even understood this one, which I have not explained yet. Great. But before that, I think it might be better to explain the previous solution, which we had discussed till this point, where we were calculating all the DP states. Now let's discuss about how will we get our answer if we have calculated the DP states. In that case, what we can do is, once you have calculated all the DP states, you know that eventually you had to pick up 2k number of elements from the complete array. So the value of I should definitely be equal to n and x should be equal to 2 into k. Now there are 128 into 128 states which are satisfying this, right? So for all the states, like all the states among these which are reachable, basically for all the states where dp of n 2k over 1 and over 2, this is 1. For all those combinations of over 1 and over 2, you can just say that, hey, the bitwise XOR of over 1 comma over 2 is a possible solution. This is like there must be a subsequence which is getting this as the score, right? There must be a subsequence for which the first k elements are having over 1 as the bitwise OR and the next k elements are having over 2 as the bitwise OR. So over 1 or over 2 must be one of the possible solutions, possible answers. So you can just maintain a variable with name answer, let's say initialized for 0, and answer would be equal to max of answer comma OR1 or OR2 for all the possible combinations of OR1 and OR2, for which this thing comes up to be 1. Right. So after calculating the DP states, you would have just used, you could have applied two for loops, one for OR1 and one for OR2, and apply this as the condition. If this is true, in that case, write this line. So at the end of the day, answer will be equal to the maximum possible uh, score you can have for any of the subsequences. Does it make sense? Have we understood on how to solve the problem with this uh, very heavy solution? Like the complexities are very heavy, but at least it will solve the problem. Are we good till here? Please tell me about this in chat. Okay, great. Sure, we understood. What about others? Yes, please say at least yes or no something. Uh, so that I will have some idea that you didn't understood or you understood. Otherwise, I don't know if some people gave up or they didn't understand. They are just not interested. Okay, so there is only one active pen. Mm. Okay, let's continue. So what we're using the idea of possible subsequences sum of an array. Possible subsequences sum of an array. Yeah, instead of having a sum, we will have all. Yeah, this is the thing which we have done is very similar to the standard problem. Possible subsequences sum of an array. The only thing is the size of the array is fixed. Sorry, size of subsequence is fixed, and instead of having sum, we are having all. And in the approach which we have discussed here, it is a bit more complicated because we are having two type of ors here. But the tricky idea here was since it is not working earlier, if we are trying to keep track of the states that out of the first I elements have picked up X elements and bitwise score of the first case elements is over 1 and the rest elements is over 2. Uh, it is having too many states and we cannot have that many states in solution. The idea was that what if we only keep track of, like if we try to pick up key elements from left and the other key elements from right instead of trying to pick up all the elements, all the two key elements from left to right in one go. Let's pick up only key elements from left. Then we will have only these states and pick up the rest key elements from right. So again, we will have three states there. The number of elements we would have picked up from the right hand side. The number of elements being covered from the right hand side, the number of elements being picked up, and the bitwise OR of those elements. And for each and every index, I can just say that, let's say, uh, maybe I can run up a for loop for I starting from k minus 1 uh, till I is less than equal to what is less than n minus k, something like this. You can check if it is n minus k or n minus k plus 1 minus 1 etc. But we can just check for this. Basically, this I is telling us that hey, till the index I am picking up elements for the left part of the subsequence for the first k elements, and from I plus 1 till n minus 1, I will pick up elements for the right hand side of the subsequence. In the subsequence, there were two parts, uh, the first k elements and the next k elements. So for every element, you can just check up that, hey, let's say I am picking up k elements for the left. So you can have dp of I and then k, because the number of elements should be k, the number of elements being picked up to be k, and the bitwise for of the elements. And similarly, you are having dpr of I, k, and over 2. Here, dpr of I is telling me that uh, all the elements which I would have picked up are going to be from index I plus 1 till the end. So for all the combinations, OR1 and OR2 and I, like there are three variables here. The k is fixed and the other three things, I, OR1 and OR2 are not fixed. So you can just try to figure out for all the possible combinations of these three things. Wherever you find out dp of I, k, and OR1 and dpr of I, k, and OR2 to be true, then in that case, answer is equal to maximum of answer and OR1s or OR. You can do something like this. Now it depends upon you in which way you would like to have the states. Some people might like to have I plus 1 here. Some people might like to have some other names or some other type of states. But this is one way. This is one idea in which you can solve the problem. So how many of you are with me right now? And how many of you are lost or have some doubt in the problem? I can try to explain some part of the problem if I feel it to be important. And there will be some parts like the implementation, which is something you will have to do on your own. Obviously, I will show you my code, but when you implement it on your own, you will have a better learning. So I highly suggest you to implement it on your own. Like whatever doubts you have, just write it in chat. I will try to resolve as many as possible. How to improve competitive programming skill like the way of thinking. It will get better as you practice more and more problems. And there is one more important thing. Like don't just solve problems for the sake of submitting it. Try to solve the problems with the aim of learning from it. As an example, I had covered the part of thinking about the greedy solution or all the observations which I had made, which gave me confidence for thinking about the DP solution. Thinking about these part is very important. Like I tried to point as many observations as possible uh, to tell you about the reason why I got more confidence for DP. Uh, but don't just depend upon me and try to think about these things on your own as well. The more you think on your own, the better it will be because when you solve problems on your own, you will be learning more things. Okay, somebody is saying we can move ahead. Nobody has written any doubt, so let's move on to the code. The code which I've written, yeah, is not very clear. I have not used very good names. For now, just yeah, let me explain the code as well. It will help you to implement it on your own. One thing which I have done is I created a function with name. I gave it a name if you can give it a better name. So what I did is I created a function with name f. To this function, I will pass on a vector of integer and I will pass it the integer k, and it will return me a vector of integers, basically a 2D array, such that it tells me uh, that like, let's say the name of this array is prefix. You know, when prefix of I comma j will tell me or I comma o will tell me that from the first I elements, if I pick up k elements, whether it is possible to have o as the bitwise or not. So prefix of I o would be 1 if it is possible to pick up k elements from the first I elements and have the bitwise or of them as o. Otherwise, it will be 0. Similarly, what I did is uh, I reversed the array which I had, the nums array which I had, to create nums reverse, and I passed this as well, nums of reverse, like reverse of nums and k, which gave me, like the logic is the same thing now. Whatever I was doing for the prefix, I'm just doing the exact same thing for the suffix as well. So to avoid writing the same code twice, I created a function and passed on the nums array and then the reverse of nums array. And the two results which I got, I named them as prefix and suffix. So suffix of I comma o will tell me that if I'm picking up I elements from the back, let's say if I'm talking about suffix of 2 comma 3, it means that I'm picking up like from the last two elements of the array, I am picking up k number of elements. Then is it possible to have 3 as the bitwise or of all those elements which I've picked up or not? So this is what this function is doing. The implementation so for implementation, I created the state itself. We had talked about the state earlier. I had written the state somewhere. Just forgot. Yeah, basically, I had created a DP with the states as DPI, X, and O. This I tells me the number of elements I'm covering from the array. Let's say I is 5, then I'm talking about picking up elements from the first 5 elements. X is the number of elements which I have picked up. So if X is 2, it means that from the first 5 elements, I have picked up 2 elements. And O is the bitwise OR of the elements. And the result will be true or false, whether it is possible to have this is the bitwise OR or not, like for any of the subsequences. And with the help of this array which I have got, I'm creating, like I'm returning this these 2D arrays because whatever I'm returning, I know that x would always be equal to k. So instead of returning a 3D array, I'm returning a 2D from the function. So yeah. I'm having these three states, and inside this, I'm having uh, yeah, two conditions if I don't pick or if I pick. And I'm having a 2D vector here. You can see it. It's just the space optimization. I have space optimized that 3D DP to 2D DP because using a 3D DP would have slowed down the solution too much. It could have given me a TLE or memory limit exceeded or sorry, memory limit might have been exceeded. At least I don't know. So this is something you should try to implement on your own. It is not very difficult, and I do agree that my code is not very clean yet. Like I have used names like O, J, and have not written the terms, so it might be looking confusing. Once I'm done with getting prefix and suffix, I'm just having these three possible variables: I, OR1 and OR2. Here I know it's L and R, but according to our explanation, these would be OR1 and OR2. In the code which I will give you in the comment section, like after the stream, which I would write again so that I can give a clean code, I would use the names as used in the explanation. So inside the three for loops, we are just checking if it is like if these two conditions are satisfied, then answer is equal to maximum of answer and else or R, and at the end I'm getting it. So is this problem clear or not? From my end, honestly speaking, I really did try to explain as well as possible. I did put up efforts, but the problem is actually a bit complicated in comparison to the standard problems. So if somebody has not done the standard problems, or if he has not done the standard problems properly, in that case the problem might still look complicated. So I would suggest that make sure that at least the basics of yours are clear. Iterative DB solution, any suggestions on how to think about iterative DB? Yeah, there is one thing I would like to suggest for iterative DB, which at least helped me. It is that once you're done with thinking about the DP state and you're done with thinking about the transitions that in which way the transitions will happen. For now, let's talk about this. Let's say if you were to write 4D DP and these were the transitions, you just need to make sure that whatever in whatever way you write those iterations, basically those for loops, this state should definitely come up before this state and this state, right? In both of these, you can see that here we are having I, and in the transitions, the states which we would be reaching at the end are having I plus 1. So it is safe to say that if you are having the outermost for loop of I, uh, in whichever way you write the inner for loops, the state which you wanted to come up first will definitely come up first. Now, nextly, what I do prefer is I have these four uh, states, right? These four parameters for my state. So I just write four for loops. I would just write a for loop for x. I know that x should at least be 0 and it can at max be equal to 2 into k. And after that, I'm having two for loops for like one for loop for OR1 and then one for loop for OR2 as well. I know about the minimum and maximum possible values for OR1 and OR2. Inside that, like once I'm done with writing all the for loops for my like for my parameters of the state, then I do write an if condition that if dp of whatever values I had. Basically, this state which I'm referring to right now by the combination of these four variables. If this thing is not reachable, how do I know if it is reachable or not? We do generally initialize uh, the DP array by something. Some people initialize it with -1 depending upon the problem and what we are doing. So right now we initialized with 0, and you know that if this state is ever reached by anyone else from the base case, it would be 1. Uh, so if it is basically equal to the uh, value which it would have if it is never reached, uh, maybe the word which I'm using here has reached might not be relatable. But basically, you just want to know that if you can actually reach this state or not. If you can never reach the state, or if you have never reached the state till now, in that case, just continue. And after that, you know what the transitions. Like there were two transitions. You know. So in this case, I have just written those two transitions straight, like directly. That if you pick, then what will happen? If you don't pick, then what will happen? So this is the way in which I do write the iterative DB code, and I just told you about the way in which I think while I'm writing the iterative DB code. For the part of space optimization and all, I think it will get better at. It will get better with time when you try to write code again and again. The same thing goes for the iterative DB as well. So a simple iterative DB code would look like this. It should be less than 1. X. And after that, you can say that you will have two cases. If you pick and if you don't pick. Right. Now, writing this part of transition of what will happen if you pick and what will happen if you don't pick, it is like very similar to what we do in the recursive DB. Yeah, there is one more thing. The way in which I have written the DP here is basically the code here is push DP. In recursive DP, we always write pull DP, we cannot write push DP. Uh, Now it is something based on preference. I always prefer to write push DP wherever it is possible. Yeah, I have seen some grandmasters also writing in the same way. I personally noticed Amnik writing this way, and then I started to write push DP. It's up to you in whichever way you feel better. I just thought of adding some extra information uh, based on my experience. Uh, So, anybody having any doubt in this problem? Or shall we move on to the next problem? The time complexity here would be we are having three for loops. So, this is big of n into k, which is n by 2. So, it's like n square into 128, n square by 2 into 128, and this is, or maybe we should actually call it as n into k into 128, and this part would be n into 128 square. Okay, so let's move on to the next problem. This is the fourth problem of the contest. Just 1 second. Yeah, this is the fourth problem of the contest, and it is gonna be simpler than the last one. Like the third problem was most difficult in my view. The fourth problem is actually simple to think as well and to implement as well. So we are given a 2D array of integers that is coordinates of length m and an integer k. Coordinates of I is going to be a pair of integers x and y, where x and y indicates the point xi, y, basically the point in the 2D plane, uh, the coordinates of the point in the 2D plane. And we have been told that an increasing path of length m is defined as a list of points. Here is a list of points such that when you're looking at the consecutive 2 points, the x coordinate of the first one should be less than the x coordinate of the next point, actually strictly less than the next point, and the y coordinate of the current point should also be strictly less than the y coordinate of the next point. And uh, all these points which we have picked up should be among the given coordinates. And we have to return the maximum length of an increasing path that contains coordinates of k. So it is like we are being given the coordinates of some points and some integer k. We have to figure out an increasing path consisting of the points which are given, like uh, the, the points from the given coordinates, such that the increasing path should contain the kth element, the kth coordinate, or the kth point. We can say 10 anyway. Okay, so we have to tell the length of this increasing path. Let me take one example. We have 3, 1, 2, 2, 4, 1, 0, 0, 5, 3. Right, and k is equal to 1. So it says that we must have this point in the path. Now, tell me one thing. Does the order of points matter? Does it matter whether the given array was this array, or in the array if 5 comma 3 was coming first and 0 comma 0 was coming? Does it really matter? Would it create any difference in the answer? Guys, tell me yes or no. First of all, tell me how many of you are actually in the loop. You can see there are 25 people, but not really that many messaging anything. Many people might have forgot those students. Okay, I can see one person in the chat. Is there someone else as well? Okay, so Pranav, is the problem clear, or do you have any doubt in the problem statement? Okay, so I hope that this thing makes sense. that the order in which the coordinates have been given does not really matter, right? The order in which the coordinates have been given does not really matter because uh, at the end of the day, we just want to find out if there is a series of some points such that for every two consecutive points, let's say if this is x1, x2, sorry, x1, y1, and this is x2, y2. So x1 should be strictly less than x2 and y1 should be strictly less than y2. And these points should be coming up in the given coordinates, but they can be anywhere. Like it does not necessarily have to be at the second or third position, it can be anywhere. So the given order of the elements does not matter, which means that we can safely assume that sorting the given array would not change anything, change the answer. Like the answer will remain the same. For solving this problem, we can just do it manually. We know that 2 comma 2 must come up in the increasing path. There is only one point which can come up before 2 comma 2 in the answer, like in the increasing path, because this is the only point which is having both values to be smaller. And 5 comma 3 is the only point which is having both values to be larger, both coordinates to be larger. So this can be an increasing path, right? So the answer here should be 3, and that is the case. So since we know that we have to pick up this point in the answer, in the increasing path for sure, can I say that I can easily remove these points? Like the points in which either xi comma y, like xi, okay, the points in which xi is less than xk and yi is less than yk, only these points can come before uh, the point which we definitely have to include in the increasing path, and the points whose coordinates xi y are greater than xk and yk can come on the right hand side of the given point, but the points for which xi is greater than equal to xk and yi is less than equal to yk, or the other way around, or xi or yi being equal to xk or yk, like all those points which are not belonging to either of these two are definitely gonna uh, be out of the possibility. For basically, we cannot have them in the increasing path. They will just not have, like they cannot come up on the left or right of the current point, which we definitely have. I think it would be clear. It should be clear whatever what I'm going to tell you. Just tell me in chat if it is clear, or is anybody still having any doubt? In case if anybody has any doubt, then I will explain it to you. So right now, same question for using VP over manual programming function. How do you do it? To be honest, by looking at your comment, I'm not able to understand about what you are trying to say. Yeah, it is possible that there might be some other solutions as well, other than the one which I discussed. Someone is asking, is not this question longest increasing subsequences for constraints? Exactly. This is the problem for finding out the longest increasing subsequence. The only thing is we are having two constraints. We are having, instead of having integers in the array, we are having an array of pair of integers. We are having an array of pair of integers instead of having an array of integers. and we just have to figure out the longest increasing subsequence, or actually you can say longest increasing subset. If you're having a point 0 comma 0 here and um, maybe 1 comma 1 here and 0 comma 0 here, you can have both of them in the subset here, like the increasing part. It's not like uh, which comes first matters. uh, Guys, please tell me if the problem statement is clear and you're able to understand that we only care about these points. Is it clear that we only care about the points for which the x coordinate is smaller than the x coordinate of the kth point, and the y coordinate is smaller than the y coordinate of the kth point? These points have the potential of coming up on the left hand side of the kth point inside the increasing path, and for the points whose both coordinates are greater than the coordinates of kth point, have the potential of coming on the right hand side. Can I say that I will figure out all the points which satisfy the condition that xi should be less than xk and yi should be less than yk? Let's say I put them up inside a vector of pair of, like, I create a vector of pair of integers, and I just store all of those points whose coordinates are smaller than the kth coordinate in this. Similarly, I create a vector of pair of integers inside which I store all the points whose coordinates are greater than the kth coordinate. Then I say that maybe we are having a function in which I will pass on this uh, vector of pair of integers, and it will return me an integer that is the largest increasing path I can have from these points. Similarly, I will pass on this function. I will pass on this vector of pair of integers to the function, and it will return me the largest uh, increasing path I can have in this vector of pair of integers. All of these, like let's say if I got 4 as the answer, then I can say that in the final increasing path, my kth point is lying here, which I was being asked to include in the increasing path for sure. On the left hand side, I will be having 4 points from uh, this vector pair of integers, and let's say this value came out to be 3, then I will be having 3 points on the right hand side. All these points, since they are greater than the kth point, they would also be greater than the points which are even smaller than the kth point. So there shouldn't be any problem. Let's say the function name is lis. So can I say that my answer would be nothing but lis of smaller plus 1 plus lis of larger? Yes or no? Does it make sense? Okay. So now the task is, how will I find out this lis, or maybe you can give it any name. Maybe let's say this is some function of, I just gave it the name lis because I felt it to be very similar to finding the longest increasing subsequence. Now in the lis we are having vector of pair of integers, right? We are just having vector of pair of integers, and the same problem which we had been given here, We are just having the exact same problem for the smaller points and the larger points. Just this condition has been removed. Like in the original problem, we had been told about a point that we had to include in the increasing path. Now, since we have already included it here. We don't really have that condition for the smaller points or the larger points. We just want to find out the longest path, longest increasing path. So I had one idea that sorting the points would not really change the answer since the order of elements does not really matter. So I sorted it. Now let's say if I sort the elements in such a way that the elements having smaller x comes first, then all the points which are having, let's say, x equal to 1 will come up here. Then the points which have x equal to 2 will come up here. Then the points having x equal to 3 will come up here, and so on. Right. Now, if I just somehow make sure that at most one element would be picked up from these, at most one element would be picked up from these, at most one from here, at most one from here, and so on. And the elements which I'm picking up, their y coordinates should be increasing. Can I say that I will get my answer? Guys, can I say that I will get my answer in this way? Obviously, I will get my answer because I know that if I'm picking up only one element from here, the reason we can't pick up more than one element from here is because, let's say, if I had picked up one element here and one element here, both of them having x equal to 1, in that case, the condition of consecutive elements being strictly increasing won't fulfill. So, to make sure that the condition of coordinates being strictly increasing is fulfilled, we can pick up at most one element from these sort of blocks. You can call them as blocks where we are having the same values of x. Now, in case if the problem had said that xi should be less than equal to x of I plus 1, if these could have been equal and yi could also have been equal, then you could have just sorted these y, like for the points whose x are same, for the points whose x coordinates are same, you could sort them such that smaller y comes first. You could do it in this way so that you would have you would have got the answer. Okay, like in case if it was not strictly increasing and it was less than equal to, then some things would also change, like here and here some things will change. But I'm just giving you a sort of challenge that consider this problem as well. Take it as a homework that think of what you would have done in case if it was not strictly increasing, instead if it was just increasing. For now in our problem, we have to make sure that xi is strictly increasing and yi is also strictly increasing. So in this case, all you need to do, like all you want to do is just make sure that from all these blocks where the value of x are same, the values of y should like the values of y can be anything. It does not really matter if these y are sorted or not, because you can pick up at most one element from here, but you need to make sure that you pick up exact, like at most one element. You don't pick up more than one. And you want to pick up as many elements as possible such that the y of them are increasing. So one possible way for this is you say that for the points whose x coordinates are same, the points whose y coordinates are larger comes first. So in that case, when your x coordinates are equal, um, since the y coordinates would be decreasing, so you would like among these, you will not be able to pick up more than one now, because like if you just apply a simple longest increasing subsequence algorithm now, uh, that algorithm will never pick up more than one element where the coordinates are having where the points are having the same x value, because the like for the points where the x coordinate are same, uh, the points with larger y coordinates will come first. So if this point is being picked up, the next point here cannot be picked. So if like either this one will be picked or this one will be picked. So what we can do is just sort the uh, points such that if the like yeah, smaller x comes first, and if x coordinate of points is same, then larger y comes first. And after that, you can just apply the longest increasing subsequence algorithm, which is a standard one. Like you can search about LIS, we can find the longest increasing subsequence. Basically, the length of the longest increasing subsequence in log n time. You can just apply this algorithm on the y coordinates, and it will work out. So yeah, this like in this problem, this was the only tricky part of thinking about this way of making the problem simple. Everything else was, I think, simple enough. Okay, so guys, what's up? Did you understand the problem? At least give me some feedback. Maybe ask some doubts about it. There can be a lot of doubts since they're having a live class now. In the meanwhile, let me show you the solution. So this LIS is a standard code. You can just easily find it on internet as well if you don't have any template. And if you have any template, you can use it. The main code is here. I'm creating two vector of pair of integers, two vectors of pairs of integers, smaller and larger. The points whose coordinates are strictly less, I'm pushing them in the vector smaller, and similarly pushing the points with larger coordinates in the vector with larger. And then I'm just returning LIS of smaller plus 1 plus LIS of larger. This plus 1 is there because of the coordinate k, which we would have picked, which is not included in both of these. And in the LIS, I'm first of all sorting the points in this way, that I'm sorting on the basis of the x coordinates, and for the points whose x coordinates are equal, I'm sorting on the basis of y coordinates. And after that, this is the standard LIS algorithm. Yeah, that's it. So the time complexity here would be this for loop will be just bit of in time, like it will take this bit of in time, and we are calling the LIS function twice here. So it is the LIS function takes bit of in time. So we are having a time complexity as bit of 2 into n log. Okay, so guys, does it make sense? If anybody has any doubt, please ask me. I was expecting more interaction in the live session. Nothing really bad, but I think it's decent. Some people are doing. For the space complexity part, we are just having Lagrangian time, Lagrangian space complexity. So yeah, that's it for this session. Thank you for watching and thank you for attending the session. So bye bye guys.